Anybody bought any Bitcoin? When it was cheap? No? Check this out. August 23rd, 2013. Bought a Bitcoin. Yeah? What's Bitcoin now? 7,000? Nice. I bought it for $100. Best investment I ever made. Some of my friends called me the Asian Warren Buffett. But my other friends know me a little bit better because later on that day I sold half of it. But I kept the rest. For 4 days, then I sold that. And the point of this slide is just to really express to you, I'm really, really good at investing money. But even somebody as good as me can do with a little bit of help every now and again. So I listen to this podcast, Planet Money. Does anybody listen to this podcast? No? A few? Fantastic podcast, 20 minutes of economics every week. And at this point, I should say I'm not affiliated with Planet Money or NPR at all. They have not endorsed me or my company. But they had a really interesting podcast last year where they asked themselves the question, have you heard of this guy? So this guy kind of likes to tweet a lot. And what they asked themselves was, sometimes he tweets about a company. So this time he tweeted about Toyota Motors. And as soon as he tweeted about Toyota Motors, the price went down. Okay? Instantly. And so they asked themselves a question, well, what if we built a trading engine, a trading bot, which could make trades based off of Trump tweets and make money, right? And that's what they did. They built it, and they actually released it on Twitter as Botas. So if you go to Twitter, a site called Botas, bot of the United States, it will tweet whenever Trump tweets something that would trigger a trade, it will kind of retweet it here and talk about the trade they made and whether it was a positive or negative trade. It was a pretty interesting bot, but unfortunately, later on in the year, they shut it down because, they are a podcast and not an investment firm. And everybody was really sad about this. But that's why I decided to build my very own Botas that would make money for me automatically. You all know where this is going, right? But no, I made money. $61 to be exact. Normally at this point people give me an applause, but it's okay, you don't have to. Okay, thank you. Now admittedly that's about 50 cents for every hour I worked on the project, but I'm chalking that up to the win column. But don't get excited though, and this talk isn't about me teaching you how to create your very own Botas. That secret stays with me. This talk is about how to architect and scale a web app like Botas. Now I chose Botas because it's one of the demos that I've created, and I chose it because it has a little bit of meat on it. It's a little bit more of a complex application. It's not just like a view and an API, it's got some other parts of it. And I'd say not that long ago, even as little as kind of 2-3 years ago, the question of how to architect an application like this was just a lot simpler. Perhaps we'd use Express or Django, or I know a large number of people here from the Drupal community will still use applications like Drupal. And I think questions about how to architect an application like this were just a lot easier. And we typically would have a view layer, so perhaps that would be a template rendering engine. You pass in some data, gives you some HTML, you pass that back. You maybe would then have a controller or something that sits between your view and your database and kind of transforms data for you. But this application also has a Twitter feed, something that actually has to sit there and listen to Twitter and react to tweets. And it also has a pretty meaty, important, robust trading engine, because you don't want a trading engine. It's got to be kind of serious code because you're trading money. But I'd say a lot has changed just in the last 2-3 years. And I think a lot changes all the time in the web space, but I think a lot has changed in the last 2-3 years. And we don't really build applications like this anymore, or currently like this anymore. Another thing we would do is we'd basically, because this application was typically built in one code base, we would normally host it on kind of a server-based architecture, right? So this logo is the Azure App Services. And that's the topic of today's talk, really. The topic of today's talk is, that's how I would have built this application 3, 4, whatever years ago. How would I build this application today, using all the latest technologies in terms of frameworks and cloud technologies? So, thank you for the intro. My name's Asim Hussain. You can find me on Twitter as Jawache. I blog about Angular and JavaScript on my website, codecraft.tv. And as introduced, I'm what's something called a cloud developer advocate at Microsoft with my friend Burke over there. Woo! So this is us. You can find that we're a rare breed. There's actually not that many of us in the world. You've actually had 3 of us in this conference. Simona Coteen's also another cloud developer advocate. So if you actually go to that link there, you'll find us. We're all online, and we're all kind of focused on open source. And what we do is we don't just advocate Azure to the web, we advocate web to Azure. So if you've got any feedback or anything to do with cloud and Azure, just come and feel free to reach out to me, or to Burke, or to Simona, or anybody here, and just give us your feedback, because the PM team loves your feedback. I'm also an instructor on Udemy. Anybody know Udemy here? Ah, yes, excellent. So Udemy recently added in automatic transcriptions for their sites. And so finally, for the first time, they correctly transcribed my name to Awesome. So my name is Awesome, and this talk is going to be very Asim. So this is what I was going to talk about. How would I build this kind of application today? Now, the first thing, like kind of application technologically, but also in terms of cloud hosting technology. And the first thing I want to explain is that little logo on the bottom. That is something in Azure. It's called an app service. It's something called a PaaS. Does anybody know what a PaaS is? Like a few hands. Okay, let me explain what this stuff means. So back in the day, really far in the past, we used to just have kind of on-premise hardware, which is basically you would buy the hardware, so you're responsible if the hard drive fails, you fix it. You would also then be responsible for installing the operating system and whatever web framework they want to use, okay? That's you. That's what we call on-premise. Then we invented infrastructure as a service, so we started using virtualization, and you started to be able to just rent out VMs for short periods of time. Somebody else is responsible for the hardware. If the hard drive fails, it's on them. You're still responsible for the operating system and your web framework, okay? And people, because we're all very lazy, we're like, oh, I don't want to do that anymore. So we invented PaaSes, platforms as a service, where we went, okay, fine. We'll deal with the operating system. All you've got to do is deal with your web framework, okay? That's a PaaS, platform as a service. There's a whole bunch of them out there. There's a really famous one at the top, and there's some other ones underneath it. But there's like a whole bunch of them out there. I mean, I think Heroku is probably the most famous one that people know about. But these are just implementations of PaaSes, platforms as a service. And so how we would build this application today, typically, is we would probably take the view layer and turn that into an SPA, okay, which extract it out, and we'd basically have it as a single page application. But what is a single page application? Actually, what is the opposite of a single page application? It's an UMPA. Oh, sorry, I mean an UMPA. Has to be, right? If there's a SPA, there has to be an UMPA, right? It's a multi-page application. I'm just going to quickly take you through it. This is my website. My website is a multi-page, an UMPA, multi-page application. As you click around, this screen is so big. As you click around, if you look on the network panel, we're making different requests to the server for different pages, right? That's a multi-page application. Multiple pages are returned from the server. So what's a single page application? This is Botas itself. Now you can see it's loaded up a page at the bottom. The page bootstraps. And then as I'm navigating around the site, the page is changing, it's updating. But if you look on the network panel, no other pages are being requested. That's why we call it a single page application, because only a single page is ever returned from the server. Okay? But what does an SPA look like on disk if you're building with Angular? Well, which of course we all are. If we're building in Angular and you did an ng build, which is to generate the output folder, this is what you would see. Now, whether your site has one URL or 10,000 URLs, this is it. This is all that would be generated. And the important thing to see here, it's just got one index.html file. That's it, right? There's only one page, that's the only page that's going to get returned from an SPA. And this is the only output folder that there'll be. Now, there will be quizzes during this lecture, and maybe this will come back, so pay attention. So, that's what we do, is basically take the view layer, turn that into an SPA, and then the question is, where do you host it? Okay, where do you put the code for that? And the decision I see a lot of people making, and I believe this decision is a mistake, and the decision I see a lot of people making is just to host it using something like an app service, another PaaS. And I question this a lot, and I wonder about this a lot. And I think it's probably because you were just hosting on that before. So now that you're building SPAs, no one's told you where to host it, so you go, okay, fine, I'll just use the same technology I was using before. So this is a pattern I'm seeing a lot of people do these days. And what I'm going to show you in this talk is there's actually a better way that's faster and it's much cheaper. Okay? The PMs hate me when I talk about giving cheaper options, but there is a much cheaper way. But to explain kind of my kind of whole reasoning behind all this, we have to discuss a topic that might seem to be quite simple, but there is going to be a quiz, so pay attention. Okay, so the topic is static versus dynamic requests, okay? A static request is a request where if the same URL was requested perhaps 2 times in a row, it will return the same data. If it was requested by 2 different people and 2 different computers, it will return the same data. If the same request returns the same data all the time, it's a static request. A dynamic request is the opposite. A dynamic request is if you request the same URL 2 times in a row and it returns different data, it's dynamic. Okay? With me? See a few nods. All right, it's quiz time. Yes. All right. So, if you request a JPEG file, is it a static request or a dynamic request? Okay, who thinks static? Who thinks dynamic? Good, excellent. It is static, that's right. There's always somebody in the audience that goes, it depends. And yeah, you're right, it does depend, right? But for the most cases, it's static. All right, what if you request the HTML for the home page of your website? Is that static or dynamic? Who would say static? Who would say dynamic? No, it depends. It depends, right? So, yeah, I used to make my homepage dynamic, right? If you were logged in, I would perhaps show something a little bit different than if you weren't logged in, right? I would make it unique, and there's also personalization issues right now. But what I'm going to show you is if you were to make it static, there's a whole lot of optimizations that you can use that make things perform just a lot better. Okay, what about a profile page? So a profile page typically is like your profile. So if I look to my profile page or look different to Berg's profile page, is that a static request or a dynamic request? Who thinks static? Who thinks dynamic? Excellent, well-educated audience. All right then, so here's the real question. Is an SPA static or dynamic? Oh. Who thinks dynamic? A few hands came down quickly. Who thinks static? Okay, excellent. It's static. You can stay, don't worry about it. I'll give you a prize later on. It's static, right? Because, I mean, if you saw what I showed you, there was an output folder, and all we're doing when we're serving an SPA is we're serving the content of a folder, right? So whether I'm visiting that site or you're visiting that site, we're just returning the same content in those requests. It's a static site, right? If you were to rebuild your SPA and change the contents of that folder, it would change, right? But if you don't rebuild your SPA, whoever's requesting that site would get exactly the same data, right? Why is that important? It's important for a bunch of reasons. One of them, the most famous reason I'd say, is caching, okay? If a request is static, you can use caching. The most famous caching behavior, most well-known, I'd say, is browser-based caching. Kind of a lot of us know about browser-based caching. If you set the right headers, it gets stored in the browser, and future requests would only get served from the browser, would never make a request to the server. But in fact, between your browser and the server, there's actually loads of nodes. It's hopping through loads of different servers, and some of those are caches. So the CDN is the most famous one, but a content delivery network, but you typically know about a content delivery network because you're paying for it, right? You're not going to accidentally have a content delivery network, right? So you're aware of it. The ones you probably aren't aware of is the proxy caches, okay? It's less and less common in countries with good internet infrastructures. It didn't used to be that uncommon even like 5 years ago in places like the UK. But definitely now in countries which don't have really great internet infrastructures, they still use proxy caches a lot. So proxy cache is something that's perhaps used by your ISP, your internet service provider. They might have their own caches sitting in their data centers because they don't want to, if they can avoid it, they don't want to send any messages upstream because they have to pay for that, right? So if they can serve it from their data center, they'd much prefer to do that, and that's a proxy cache. So what happens if you are kind of caching a proxy cache is essentially this, like your user might then make a request from the browser, and it would look in the network tab as if it's a full-on page request, but it's going to get served by the proxy and get sent back. Now the proxy you don't pay for. That's your ISP. This is free traffic. Yeah? I told you I was good with money. But how do you actually take advantage of this? Well, you basically have to use certain caching headers, right? So there's a whole bunch you can use. This is the most famous of which is cache control. The important thing there is public, right? Because your content is static, because it's the same request for different users will return the same data, you can use public. And public means store this content on kind of public servers, so proxy and CDN and stuff like that. That's what public means, right? Now the MaxAge, SMaxAge, that's just telling the different caches how long to cache this data for. I think it's quite, if you ever want to cache your HTML, keep the cache short, like 5, 6, 7 minutes. It's good because then if you ever get like a surge of users, then you're only going to get like a request every 5 minutes. But it's short enough so if you ever did change your content, it will eventually invalidate and the user will eventually get some new data. Arrows. The other advantage is in serving, okay, serving content. Because actually I'd say that there are servers, web servers that are optimized for serving static content, and there are web servers that are optimized for serving dynamic content. Okay, there's different server technologies here, right? I'd say the most famous web server for dynamic content, or my favorite, is Node, right? So with Node, you're always going through like a JavaScript layer, okay? So that's what enables you to add kind of dynamism to your request, because it's executing some JavaScript for each and every request, right? You can use other web servers that perhaps more optimized for static requests. There's Nginx, and with Nginx you can just say, oh, read a file from this, send it back out. There's no JavaScript, there's nothing in between, and it's written in C. And in fact, there are some really low-level C kind of kernel APIs where you can just start saying, start reading this file from disk and start streaming it back out on the HTTP connection straight away. So it's really, really efficient. Okay, it's really, really efficient at serving static content. And that's what I'm going to say is basically use a service that is optimized for static content. And I think a mistake I see a lot of people make is they chuck the SPA on a PaaS, put Node in front of it, and think they're happy, but you're not being as efficient as you can be with your code. So a service that's optimized for static assets on Azure, which is my team, is Azure Storage. Now, if you are on Amazon or AWS, this will be S3, it's the equivalent of S3, okay? But it's basically the same solution. It's optimized for serving static files. It's fast and it's super cheap, right? So this is a video I made, very, very basic video, where I'm just using Apache Bench to request the same content. Once is hosted on an app service, the other one is hosted on storage. And now we awkwardly wait for the other screen to finish, and it's still going. And now, wait, is it? Yeah, okay, good, it's done. Right, so, okay, you saw storage was much, much faster, made 10,000 requests really, really fast. Now, admittedly, I didn't tune the app service. I can tune it to make it more performant. But the point I wanted to make was, I didn't tune this at all. That was just default behavior, right? And as developers, I don't really want to spend a lot of effort doing kind of DevOps-y stuff. I just want to ship code as fast as possible. So that's what I'd basically do now, is I take the SPA and you host it on some sort of storage solution, because SPAs are static, and we want to use a service that is optimized for serving static assets, right? And so on Azure, that's Azure Storage. On an Amazon, it's S3. There you go. But like, what about these other boxes? Okay, normally kind of the story ends here when you watch kind of presentations, but that's what I wanted to talk about here. What do we do with the rest of the application? We're taught so much about how to build an SPA, but we're not really taught about what to do with the rest of our application, okay? And typically I just kind of see people keeping it where it was. But to discuss that, let's talk about another technology called serverless. Has anybody heard of serverless here? Has anybody used serverless? 4 or 5 people, cool. All right, I'm going to give you my definition of serverless, which is often different to everybody else's definitions of serverless, which is then again different to everybody else's definitions of serverless. So here's a graph. On the x-axis is time, on the y-axis is load, and this might be kind of the load of your application over time. Now back in the day, I still actually remember getting emails from some senior management saying, Asim, go ahead and predict the next kind of 2 years worth of peak load so we can buy the service to stick in our data centers to handle that load. And that's what we basically have to do. And hopefully we got it right. We never got it right, but hopefully we got it right. But the problem here is you're basically, you're paying for a whole load of servers that you're never using. That was kind of the big problem for a long time. So then that's why everybody loved kind of infrastructure as a service, because then you could just get a server online and switch it off when you don't need it. But you then had to kind of figure some way out of predicting the load. And actually predicting the load of a website is really hard, right? I mean, you don't know whether the next request is the last request, or whether there's 10,000 coming, or whether they're going to come in a minute or an hour. You don't know. You have no idea what the bursty nature of traffic is. Actually predicting load is a super hard problem to solve. So what you want to do is you want to have something like this, okay? Someone else does the scaling for you, and you only pay for whatever you use. That's it. That's serverless. You pay only for actual usage and not for predicted usage, and it's auto-scaling. It's pretty much it. You can take a service and just charge differently for it, and it's serverless. It doesn't have to be a whole other technological stack underneath, right? So, and it has to have auto-scaling. All right, quiz time. We like the quizzes. I don't have any t-shirts, unfortunately. I'll give you a high five. All right, so given the definition I just gave you of serverless, is Azure Storage serverless? Or S3, whatever you want to think of it. Who thinks it's serverless? 1, 2 hands. Who doesn't think it's serverless? 5 hands. But think about it, right? If it quacks like a duck, if it walks like a duck, if it tastes like a duck, it's a duck, right? So with Azure Storage, you don't have to predict usage. You put your files there, it gets served, and you get charged just for the bandwidth, right? So you don't have to predict future usage. And also auto scales for you. Like, there are servers sitting under these storage solutions like S3 and Azure Storage, and they are scaling up. They really are, right? You just don't see it. So that's why I say Azure Storage is serverless, right? And we love serverless. Serverless is cheaper. It scales down when you're not using it. It scales up when you are using it. And there's no effort. There's no effort to use it, right? It's kind of called minimal DevOps. And if you're building an SPA, then an SPA is a static site, and therefore you should be using a service optimized for serving static sites, and that is Azure Storage. So if Azure Storage is serverless, then your SPAs are being hosted on a serverless framework. So can you make the rest of your apps serverless? This is why I say serverless is the perfect companion to SPAs. Right? So the question is this. Can you take perhaps the API part of our application and make that serverless like your SPA, right? And the answer is yes. There's other serverless technologies out there. One of them is called FAS, Functions as a Service. Okay, but to explain FAS, let's go back into this diagram here. So the story didn't end on PASs, didn't end there. People basically noticed, well, all I'm doing with a PAS is I'm putting a web framework on my server, and then I'm calling a URL that's just executing a function. That's all I'm doing. All my web framework is doing is linking a URL to a function and executing that function. Can we abstract that out? Because I don't even want to deal with a web framework. I just want to put a function somewhere and say, this is the URL to that function, go execute it for me. And that's FASs, Functions as a Service, right? So on Azure, that's called Azure Functions. On Amazon, it's called Lambda. On IBM, it's OpenWhisk, I think. I don't know. But the key thing is that we charge by gigabyte seconds plus execution. So kind of the amount of memory it's using, how long it took, plus the execution. So if you don't call a function in a month, you get charged 0. Okay, so unlike a server where you have to pay for the server, if you call a function, you charge 0. And we just charge you for kind of how much you're using in terms of compute, right? But it does have limitations. All of them, all the different providers of serverless technology have limitations. Ours is limited to 5 minutes. I think Lambda is limited to 5 or 10 minutes. And it's stateless as well. So you can request the same thing multiple times, and you can't rely on the state that exists. How can you create an Azure function? You can use a variety of different tools and techniques. You can go into the portal and kind of code up in the website. I like using VS Code. You just saw Burke's demo on VS Code, where I'm a recent convert. Burke converted me over. And one of the best plugins in VS Code, I think, is the Azure Functions plugin. And then you can just click it, create a function container, and then you can create an actual individual function. It's kind of a HTTP triggered piece of code, right? It kind of adds some stub code. You can just drop a breakpoint in wherever you want, hit F5, and we're running and debugging our application in about 30 seconds, right? So even with kind of this even though you don't have a web framework and you don't have kind of the stuff that you normally kind of feel used to having, with Azure Functions, you've still got kind of that local debugging capabilities, right? So it's pretty cool. So today, I wouldn't use, I used to be like a Django developer and an Express developer, so I wouldn't use kind of Django or Express to kind of host and build my API. I would basically take that out and use some sort of serverless technology to host it, right? Because SPAs, as I explained before, perfect companion to serverless. What about the rest of our stuff here? We've got a Twitter feed and a trading engine. Like, where do we put that? Now, at first glance, it might look like, well, I'll just put them as Azure Functions, because you can actually trigger a function even based on like a cron or like a timer or anything like that. It doesn't even have to be a HTTP. You can trigger it using a variety of mechanisms. But there's problems with this, right? I mean, especially with something like a trading engine, it needs to be a bit more robust. Something needs to manage it. I want retry logic. I want to make sure that something is kind of looking after it and maintaining it. I don't just want something being in the middle of a trade and it's taking longer than 5 minutes and it just exits, right? There's nothing that kind of can look after that, right? So with serverless technology, there's kind of this concept called orchestration. Serverless architectures, there's a concept called orchestration, right? So there's something else. There needs to be something else that's longer running, that's stateful, that needs to manage all of your stateless kind of serverless functions, okay? And if you think about it, like what is the thing that orchestrates your API for your websites? Right? It's your browser. Right? Your browser's orchestrating your API. If the API request times out, the browser might try retrying. The browser has the state of knowing what the hell's going on, and it can apply whatever logic it needs to do to kind of recover from issues. So the browser orchestrates the API. So we need something that's like the browser, that's long-running, that's stateful, that can orchestrate our Twitter feed on our engine. And this is why I see a lot of kind of architectures these days with SPAs and serverless. They kind of have this then on the other side. They still have something that looks like a server, because this thing is long-running. It's not going to turn off unless you turn the server off, so it has state. So this is an architecture I see people running these days, right? But there's better ways. There's much better ways. If you're using Azure, there's a feature we've got called Logic Apps. There's not really an equivalent to this in other frameworks. The closest thing in Amazon is something called step functions, but that's like very different. But it's kind of like, who's used IFTT or Zapier? Yeah? This is like that, but at a lower level. So you can probably see here, you can see it's got some control flow logic, for each, do until, conditionals, things like that. But it has the other features that Zapier's got. So you can actually have connectors. So I've got a connector here. So it's going to start a workflow when there's a Twitter tweet. And then that's going to get some, every time somebody tweets, it's going to turn that into JSON. JSON is going to start a flow. My Twitter engine actually does some sentiment analysis. So I actually pass it through some APIs to kind of enrich the tweet with like, is it a positive tweet? Is it a negative tweet? What is Trump talking about? Which country? That's the APIs there. And then at the very end, I create another Azure function. I pump all that data into there, and I can then execute it. But the cool thing about Logic Apps is that you get charged by the number of executions, right? So think about serverless. You don't have to predict future usage. You're only going to get charged for however much you use. So this is serverless. But the cool thing about it is it runs limited to 90 days. So it's more stateful. So you can use Azure functions to kind of orchestrate a lot of your functionality. And that's the way I build a lot of my applications these days. If I can, I would like to take something. So here I take the Twitter feed. That's a Logic app. And I take the engine is actually another Azure function. But the Twitter feed orchestrates it. So if the trade ever kind of fails, it will retry it. And then I'm not using a server anymore. And the whole of my application stack is now serverless, right? And I love this. I love kind of architectures like this because I've got my SPA. My SPA is static. So I use Azure Storage, which is a serverless technology. And now all of my stuff is serverless, which really means I don't really have to deal with DevOps in the slightest. I just push my code, and it scales for me, and that's it. It's done. One other thing I just want to quickly mention before I finish is a new thing called durable functions, which is just another way of solving the orchestration problem. It's brand new. We just released it for C#, and we've just gone into preview for JavaScript. Okay, it's a brand new feature. It's pretty cool functionality. Does anybody use generators or experience with generators in JavaScript? A few. Okay. So it's kind of got a generator-like syntax. So this is actually just like a function endpoint, same as you had before. So you can see here the star, there's a generator function, and you can see here there's like a yield, right? So typically with a generator function, once it gets to the yield point, you can see the yield is kind of calling another function, right? Typically here, the function would exit, still stay in memory, but exit, and you can do other things, and then you can re-enter the function at that point later on and continue processing, right? That's the way a normal generator function works, but it kind of stays in memory, right? What we've done with durable functions is that you can actually, once it reaches the yield, it will kind of exit, and the function can leave memory, which means you don't have to pay for it. You're not paying for anything running, right? And actually, you can even wait for like 2 days. 2 days later, the asynchronous function can come back. It will literally load from disk the archived version of this function, reinflate it, and get you right back to where you were in the yield and carry on processing. It's a pretty exciting technology. It's based on something called the durable framework. And yeah, it's just gone into preview for JavaScript. To be honest with you, I haven't had much time to even play with it myself. I just want to show it to you to give you another option for orchestrating your applications, because sometimes the GUI controller, the GUI logic of a logic apps isn't powerful enough, and you just want to write code to orchestrate things. So yeah, that if you're using durable functions, you could actually just have everything sitting as an Azure function. So that's it. To summarize, SPAs are static. We can therefore use caching and serve using Azure Storage or some service that's optimized for static assets. And oh, by the way, storage is serverless. So you might as well make the rest of your application serverless as well. So use a FAS, like Azure Functions for your API, and orchestrate with durable functions or logic apps. So thank you very much. If you want, you can make sure you can always follow me on Twitter. I can wait. Oh, I'm super short. Any questions?
Yes.
Oh, no. I hate questions.
There's loads of questions, actually. I'm not sure we're going to get through them all.
Okay.
Top voted question from Carsten is saying, what if the workflow, CMS, Git, Jira, Jenkins, etc., in the company is so complex that it takes a day to make little changes? Is mockup faster? Is mockup faster? Isn't a mockup is faster?
I think is the question. I think the question might be the logic of logic apps might be too simple to do a workflow.
Possibly. Answer that one.
Okay, fine. Well, that's I think that's true, and that's why we kind of came up with durable functions, where you can actually now write code to do all that logic for you, because like everything you can do in code, you can do everything in code, hopefully, right? But I would also say one thing is that quite a lot of companies are using logic apps for a lot of their very complex workflows, because you'd be surprised, you can do some really complex things with logic apps. And I didn't really show you. I can do a whole talk on logic apps. They're awesome. I'm kind of like a GUI person. I prefer using GUIs than coding, to be honest with you. But you can even debug with it, and you can have scopes, and you can do quite a lot of complex functionality with it. And it's got really good developer tooling as well. So, yeah.
Okay. Next question is, how would you handle the performance trade-offs when server-side rendering dynamic data versus static files? I'm a designer, so some of this is a little bit over my head, so you'll have to forgive me. I'm just reading them out.
The performance overhead, how we handle the performance trade-offs when server-side rendered dynamic data. When server-side rendered dynamic data. Well, server-side, static data returned from the server is going to be faster than dynamic. I'm sorry, I don't understand the question.
Yeah, I feel like I'm not helping either. Okay, we'll just move on to another one. Okay. Where's it gone? SBAs are great for us as developers to save costs, but do you see any downsides for users? This is a good question, actually.
Oh, okay. I think the SPAs have like a lot of benefits for users as well. I think with the way I think of an SPA is actually the same way I think of like downloading an application on your phone, right? It's going to be like potentially a larger initial download, but then after that initial download, the performance for the user is going to be a lot faster. And I think that's one of the real benefits of SPAs is once they've kind of downloaded the initial bundle. And actually these days, it's quite clever these days. We can actually chunk the bundles and just have things so that each route is returning kind of a smaller bundle size. So it's not really that big an issue anymore, but definitely it is a larger initial download than perhaps like a static site, because it is using a lot more JavaScript. But I think the eventual experience for the user is really good because it's really, really fast. Because once they're navigating the page, there's no waiting for a page request to come through. There are places like my personal blog is not an SPA. It's not an SPA because there's still issues around SEO. Okay, so my blog, I need to be Google indexed like crazy. So I just have it as a static site because Google still is better at indexing static sites. It can actually index SPAs now as well, though they are using JavaScript in the crawler to go through and look at the content of an SPA. But I don't know how good that is, and I wouldn't risk changing my blog over to that just yet. Maybe wait a couple of years.
So in terms of UX, it's a bit of context, basically. It's not a perfect solution for everything.
Yes.
Okay.
Yeah.
Right. Next one. If SPA uses server-side rendering, it couldn't be hosted on a storage service, could it?
You mean if SPAs are server-side rendered?
Do you want to just read them?
Okay, go on then.
Okay.
All right. If a SPA, that's actually really good because it is if a SPA. Not an, but it is an if you say S. Anyway. If a SPA uses server-side rendering, couldn't be hosted on a storage. No, it couldn't. So what you're talking about is kind of isomorphic JavaScript. So where like so in Angular it's called Angular Universal, where you request a page, and then on the server side, it returns back to you kind of what that SPA would have created eventually on your site, and then eventually your browser kind of takes over, right? So it's kind of some pretty exciting technology. It does solve a lot of that SEO stuff I was talking about. And no, you couldn't use storage for that. You can actually use functions. So there's somebody who literally wrote an article a few days ago about how they managed to get kind of isomorphic, I think it was Angular Universal, running on one of those function apps, right? So not the storage, but the functions. Yeah, so you can actually do it that way, but you wouldn't use storage for that solution. Yeah. Okay. Yeah.
Okay, someone is asking, can you use clean URLs on Azure storage?
Someone knows their stuff. Where are they? No, yes, you can, because we've been working very, very hard with the Azure Storage team. It's currently just about to go into preview, but yeah, you will very, very shortly be able to use clean URLs on Azure Storage.
And last question from the Slido. You showed detect sentiment. Wow, that looks magic. Can you say a bit more about what that does?
Text sentiment analysis. Yes, okay, fine. So that's a whole other, I have a talk where I talk more detail about Botas itself and how to build Botas. Because if you think about it, if you get a tweet, you then need to figure out kind of, is it a positive or negative tweet? And you also need to figure out if it's, like what is the tweet about? Like if you want to make a trade, like what is it really about? And so you can use something called sentiment analysis. There's a whole host of APIs that are available these days where you can do a lot of complex kind of artificial intelligence. So on Azure, it's called the Cognitive Services Suite of APIs. There's like dozens of them. We have so much fun playing around with them. The text sentiment analysis is just one where you can throw it a bunch of data and it will tell you kind of what is the positive, negative sentiment of that text, and also what are the key phrases of that text as well. But there's loads of others. The one I've played around with so much, just because it's such insane amounts of fun, is the Emotion API, where you can take a picture of somebody's face, or I can actually I can take the whole audience right now and tell me the emotion on everybody's face. And in fact, one of our colleagues, Brian Holt, he did something where, as he's doing the talk, it's like gives real-time feedback on everybody's emotion on their faces. So yeah, there's loads of fun APIs like that knocking around, and I love them. And I'm going to talk about this for a little bit actually now. I'm going to talk.
You've got time.
This is my other talk that I do. This is another really fascinating interest that I have is AI. And I think start of this year, when I was at a conference with Sarah, we were at Agent Conf, and I was told at the end of Agent, they said like, Asim, you're the last talk. just say something inspirational. And I was like, what? I don't know. Just on a high note. And so I went out on stage, it was like in January, and I said, the talk was a little bit about AI, and I went, 2018 is going to be the year JavaScript developers get involved in AI. It's going to be the... And I was like, okay, it's a little bit of BS, but let's just keep it going. And then like literally two months later, they released TensorFlow for JavaScript, right? So now you really can do deep machine learning in JavaScript. And I've created a meetup group in London, AI JavaScript London. We're doing workshops on it. So yeah, there's like literally AI and JavaScript. We're there now, right? And you know what we're like? We get everywhere, right? We're going to take over AI. We're going to get in there. Everybody's going to hate us for it. But we're everywhere now, so we're good.
Exciting times. Okay. Anything else? You've got a few more minutes? No?
No, I'm good.
Okay. All right, we'll give it up for Asim.